Hi, I'm still Pete. I work at Just Eat. I've been there for about 5.5 years, and I'm going to talk to you about the experience I've had shipping software there and the organizational change and culture changes that have happened to let me do that easier. To put that in context, Just Eat are an e-commerce business. It's a reasonably challenging business, even though it's just shipping pizza. We go from totally unknown customers to an online purchase to food arriving at your doorstep within a 45-minute cycle, which is a pretty crushing fulfillment cycle, especially when you consider we don't have too much insight into the operations of our partners. So all of those takeaway restaurants at the end of your street are our partners. As you might imagine, they're not so tech savvy. They're not so attuned to, clicking buttons and doing stuff in the restaurant that they wouldn't otherwise already do, and that's usually just answering the phone. So we do that. We do that at scale. We do that in AWS in a cloud native way, and we've been doing that since 2001. When I joined, we did maybe 10 changes to production in that year because, we didn't really know where production was for a start, or where the servers were, or how to get to them, or how to test any of the software that we had, and it was different versions of software on different servers, and we didn't know how to build it, and all of those sorts of problems. And then production itself was kind of a bunch of snowflake servers put together by who knows who, and maintained, and a bit maintained and patched, and different server versions, and it was a mess. So to put that in contrast, last year, 2014, we did more than 800 changes to production, and we know where that is now. It's in Ireland. It's in the AWS cloud there, and all of our infrastructure is source controlled. All of our code is source controlled, and none of our code is built on developer workstations in debug mode. And we know where the build agents are because they're also in Ireland in the cloud, and they're repeatably built, and so on. And it's nightmarish chaos now, right? I don't know what's deploying today, yesterday. Something might be deploying right now. I hope not, because I'm on call. And basically, how do we keep a lid on that? We've gone through some changes, obviously, from 2010 to now. We've accelerated the pace of shipping code, and we've also got better at talking to the business and finding out what code they want us to ship. A bit better. We've improved our confidence shipping code. So at the moment, we're devolved into, 12 or so small teams that don't collaborate. They are isolated and independent, except when they can't be, right? So those teams own the code that they ship from the keyboard to in production. By that I mean they're reviewing each other's code when stuff gets committed. It's a pull request model, very similar to open source. And every developer in a team is on call for the components that they're shipping code to. Sometimes to components that they're not shipping code to because they've adjusted something, and the team that owns that thing is saying, well, yeah, okay, you can change this, but you're on call for it. So you immediately have a very high incentive to do a really good job. That incentive is, we're a high volume e-commerce business, or reasonably high volume e-commerce business. We do about 1,200 orders per minute at peak time, except we add another 50% on top to prove that we can. We run fake load in production. And if you think about that, we run fake load in production because we can react to problems in real time. Not real time, near real time. And some of these capabilities we couldn't even dream of 5 and a bit years ago, but now we take them as granted. Take them for granted. So everyone's deploying everything all the time. It's an exaggeration, but I wouldn't know that a deployment is about to happen because people announce when they've done it as opposed to when they're going to do it. So there's no real chance to say, no, hang on a minute, unless you're already sort of in the loop. So that's one of the cultural changes. knowing what's going on, situational awareness. By that I mean knowing what other people outside of your team are working on. Knowing what the people inside your team are working on is a kind of precursor. And 5 years ago, that didn't happen very much because we were kind of individual contributors. Now there are teams. One of the things we've got better at is knowing when something is on fire before our customers are, and knowing about that. So we have kind of near real-time monitoring. We use StatsD Graphite and an alerting tool called Siren, all open source. And then we know a bit of context around what's going on because we ship our logs to some central source. We use the Elasticsearch Logstash Kibana stack to great effect. I haven't mentioned, but it's worth mentioning, we're a Windows environment and we're doing this reasonably successfully, pretty successfully compared to quite a lot of the people I talk to. We've invested quite a lot of time and effort and, well, blood, sweat and tears into that continuous delivery, continuous deployment pipeline. We've written our own set of tools on top of what AWS provide. We've source controlled the infrastructure. We've source controlled, well, our code. And now we have a reasonably frictionless pipeline to production. And so we also know what's happening in production quite quickly. So we're at the point where we might take away the manual step to actually do the last push. We might. We don't know. One of the other cultural differences that I see is our teams are quite autonomous. So remember I said we're on the hook for the code we ship. We have to care deeply about whether we've done a good job or not. That means that I might get called. So, as I say, an incentive to do a good job. If I don't do a good job, it's really easy for someone else to roll it back, and that's fine. That's, again, part of the culture. We expect to, every now and then, fluff it. That's a really powerful place to work, because you can try something, or you could be not 100% confident that something's going to work, but ship it anyway, and if it does, then great. You've just saved some time, some effort, some opportunity cost of writing that last test or whatever. And we have the freedom to experiment. Because we're operating as a cloud native, because we're fully bought into operating in the AWS cloud, we don't abstract away the, I don't know, we don't hide DynamoDB behind an interface. We don't hide what another SNS or SQS, their pub sub and queuing services. We don't hide them behind an interface. We buy into the fact that we're probably never going to swap clouds, and that buys us not having to write all of that abstraction layer, so that it's like someone trying to say that, oh yes, we're using an ORM partly because that allows us to swap databases. How many people have actually ever swapped databases? You're nodding, or you're agreeing? Yeah. So that decision to jump into AWS 2 and a bit years ago has really paid off in terms of accelerating our deployment tempo, our delivery tempo. So I mentioned 5 years ago, 10 deployments-ish, a few rollbacks, not counting those. When we migrated to the cloud in first quarter of 2013, we had our highest uptime recorded for the last 12 years in the quarter that we migrated our hosting provider to a totally new thing. So that was reason number one, retroactively, that we did that. And then the pace of releases just accelerated when we moved to the cloud. We did something like 300 in that year and more, and then 800 or more last year, and probably 800 already this year. We find one of the things that operating in this way allows us to do and forces us to do is to become more data-driven. So previous to moving as quickly as this, we would find that changes were a lot more loosely justified, shall I say. I think it would be a great idea to allow pizza on the site as opposed to curries. Okay, we'll do pizza. That didn't turn out so well. That sort of thing. Contrived example, but now, because we have stats, because we have logs, because we have business intelligence parsing those events that we publish, because we're increasingly an event-driven unified log type platform, we find that we waste less time in meetings. I'm not saying we don't have meetings. I'm just saying we waste less time in them. It's because it's easier to make decisions based on, well, look at this data, look at that data. Okay, that is clearly the thing we should do. I exaggerate, but that's roughly the pattern. You have fewer arguments because it's really difficult to argue with data and visualize data. And look, here's a spike, or look, here's a rate of change increasing. We should do more of that or less of that. At one point, so that there have been a few step changes, I guess, in our operational competence, in our delivery tempo. I think, from my point of view, the first one came about 3 years ago when we had our first hackathon. We, at this point, weren't in the cloud yet. We were talking about moving, but not actually anything concrete yet. And someone hacked together a statsd graphite monitoring stack because that's the thing that we thought would work. So after a morning, we found a bash script that would launch an EC2 instance and install statsd and graphite, and it would kind of sort of work. And then the next day, someone had hacked together the metric publishing from our main order processing application. Basically, it sits in a loop, polling and waiting on orders to arrive in a database table and does stuff. So now, brilliant, we can count the loops and we can time the loops, and when the time increases, we know we have to, well, do some work, and we have insight. We know what's going on in production. This was unheard of, and so we started graphing all of the things, not just the order processing loop. It's kind of addictive. So that was the first step change, basically having insight into production, and not just the operational team. At the time, we were not a cross-functional, there was a wall between development and operations. Operations were kind enough to not secure it, and so developers were able to pound it, asking for data, and so they did. And now developers are, well, they're aware of the pain that operations are going through when developers ship a release that's bad. And that's immediately an eye-opening thing for a bunch of developers that, well, were shielded from that by operations carrying the can. So we had some dysfunctional pieces to our organization, which this helped to fix. I'm not saying that's the only thing, just, this was one of the first eye-opening moments that I remember about, oh, wow, yes, you really don't want me to change things without running some performance tests and so on and so forth. I'm a developer, just for reference. I've worked in an operations team, and yeah. The next step change I think I recall is when we introduced the centralized logging. By centralized logging, we had a solution for this. Basically, we had a cron job, a scheduled task on our Windows boxes that would every 10 minutes ship all of the log files into S3. So at least they're central, right? But you still have the problem of, well, I don't know which server had the problem, so I'm going to have to go and download all of the logs. So gigabytes later, that's not really a sustainable model when you're dealing with a problem that's, well, pressing in an evening because people are hungry and they're shouting at you, where's your food? Where's my food? Where's my food? So another hackathon. Somebody had the idea to use the Elasticsearch Logstash Kibana stack. We found a tool called NXLog that we could run on Windows, which would monitor log files for new lines and ship them to Logstash. They would get shipped to Elasticsearch, and they would appear in Kibana in much the same way as Graphite made monitoring easy. Elasticsearch made logging easy to read. That didn't mean we were logging anything useful. We had to learn how to do that. Oh, this is the 97th iteration of the loop. Thanks. Very, very insightful, very useful. So now we're doing things like logging structured data, and we're aware of what debug means versus warning means and that sort of thing. But again, we're learning by doing. We basically, I think, broke down the traditional wall between development and ops around the time that we moved from a data center to the cloud. I don't know whether it's correlated or causal, but that's roughly when I think that happened. Developers were on call before then, but they were kind of a last gasp of an operator doesn't know why the CPU is running hot. Let's ask a developer, as opposed to a developer is the first person being called. And if you think about it, it makes kind of sense for the developer to be the first person that's called, because they wrote the code, or they were in the team of the people that wrote the code. In historical times, for us anyway, we would have an operations team do the deployment, and very rarely would they ask, well, what did you change? What should I expect? What am I deploying? And so they wouldn't know what they're deploying or what to expect or what logs to look for or anything like that. And so it makes quite a lot of sense to go directly to the people that do know what the problem is. And it also gives them an incentive to write down the sorts of things that are the problem. One of the great things about Graphite and Kibana is it lets you store up that knowledge. So we find ourselves exploring logs, exploring metrics in dashboards. We don't look at those day to day. We have alerts. We have the computer do the job of looking at those and telling us that there's something interesting happening. But when you get an alert that you haven't seen before, that's unexpected, or perhaps it's from a call center agent, or probably more like a supervisor, that saying, hey, payments are running slowly, or search is not finding the right restaurants, then as part of the root cause analysis after the incident has stopped being on fire, or after you've done whatever the thing is that you're going to do to fix it, part of the root cause analysis is now let's create some dashboards that show that it's this problem, so that the next time the alert fires, we can have changed the alert to link us directly to that dashboard to say, is it this? No, it's not this. It's something new. Fuck. Or yes, it is this, and this is what we did last time. So the mean time to react is shorter, and the mean time to repair is shorter. And by doing the thinking up front, by writing the test, the alert up front, you're buying yourself that time to think in production. One of the things we've had a lot of success with developers being on call is kind of changing the language a bit. So operators think of alerts, developers think of tests. Developers that are operating until they have to don't write alerts. So we change the words we use. Hey, could you please write this test that continuously runs that asserts that the response time is always less than this? Oh yeah, sure. What was the big deal? So now we have those alerts that continuously run in production and in QA, because why would we have a QA environment if we didn't have alerts there, right? That's a thing that we have to teach most new developers that we hire. How do you know that your application is working? Well, I'll run my tests and it'll tell me that it's working. Okay, great. So your tests, they create some data, they delete some data. Are you going to do that in production? Oh, no, I'm not sure. Okay, so what are you going to do? Well, production's a bit of a scary place for developers that aren't used to it. So we kind of lead them to the conclusion that if you admit that there are lots of variables, and one of the ways to trim out the noise is to write alerts that assert what good looks like roughly, then you're going to be in a more predictable place. So things like response times must always be below 200 milliseconds for this operation, 500 milliseconds for that operation. Okay, great. Now there's an alert that won't let you get any worse. Same with code coverage, right? Exactly the same concept. Don't allow yourself to slip back. Don't allow entropy to creep in. Or let's say you're talking to a database or a cloud service and you don't want your response sizes to be more than 2 kilobytes, because above 2 kilobytes, problems start, whatever they might be. Okay, so stat out the response sizes and have an alert to say that it shouldn't get bigger than that. And so you've, again, locked down, eliminated variables. This is still a thing that's very much a work in progress, but we're making progress. The biggest thing, I guess, is the mind shift of getting developers who haven't operated in production to care about production. And I guess the biggest success we've had in breaking that barrier is making it really easy to debug in production. Don't debug in a debugger. That means that you're not publishing the knowledge, you're not writing the log that allows you to see what's going on in production. In fact, don't use the debugger. Make log statements. Make debug log statements so you can turn on debugging in production, see what's going on, and then know what's going on. And because you can take that back to your test runs and see why things are failing. Write fewer unit tests or unit level tests and more integration level tests. Most of the platform is in the process of being decomposed into, I won't say microservices. Shit, I just did. Into, I guess, islands of loosely related functionality. And so there are strong contracts for these internal APIs and these internal workers. The workers process messages. The internal APIs are speaking HTTP. And the contracts between them are closely controlled. And if we make a breaking change, then probably we should have told the people that depend on us that we're going to make a breaking change before we actually make it. Sometimes we're good at that, and sometimes not so much. What this means is, because we're agreeing on the contracts, one side can deliver in parallel to the other side because we stub out the HTTP request or the message, and that's a really easy stubbing out. For an HTTP, what we do is we have a proxy that records, you can record a response, and then you can play it back, and if the contract hasn't changed, then you can be good. And we're increasingly preferring tests that are full stack. So in an age of SSDs and fast running tests, it's less relevant to have tests in memory only, and call those unit tests. Our unit tests are actually, the unit is bigger. And because we have logs and because we have stats and because we can see that when we're running tests, we can see where the problem is. And so that allows us to actually refactor inside of the API with impunity, or much more impunity than if we had covered the whole thing in a plethora of unit tests, because then we're coupling ourselves to that particular set of implementation. So we do that more. One of the other things that helps us a lot, other than keeping everything in source control, is establishing and agreeing on conventions and agreeing to be consistent. That doesn't mean that we think up front about what those conventions are going to be, although some do, some don't. What it means is, once we've agreed that a particular convention is worth having, then the other people that are not complying with it, comply with it, start complying with it. That's a priority, because the cost of inconsistency means friction and unexpected things and slowing down shipping product, I should say. Again, that's a work in progress, but we're working on it and it's getting better. For example, we introduced a deployment service rather than hosted deployment automation. So now we have an API we can call internally that we wrote to go and deploy a thing to an environment and a tenant, and it goes and does that. as opposed to a bunch of scripts that you check out from source control, and so you have to be sure of the version. Now you go to a central service and it does that for you, so it's more predictable. And one of the things it does is it eliminates the 5 different conventions we used to have for DNS host names. We're multi-tenant, so we operate for 8 or 9 different countries. Each country is a tenant. We have something like 28 different environments, and some of them are production and some of them not. And then there's the workstation case, and so there's quite a lot of different host names, especially when you consider there's 1 environment or 2 environments per team, and the team has its own subdomain. And so various different people thought, oh, I will call it tenant-feature-environment.team.thing, or I will call it feature-tenant- just confusion. It's meaningless. Get the computer, figure out what you want. Everyone comply with that. It's automation. Use it. It's really valuable to invest effort in automating conventions and automating checks for conventions, and so we do that a lot. What else? Soft stuff. So I've talked a bit about technologies and what tools we use, and a little bit about developers being on call and logging and monitoring and metrics and alerting and stuff. I haven't really talked about the team organization. We've got about 200 engineers. It's not one big team, obviously, that would be insurmountable. Not everyone's working on the same code base at the same time. That's why we decomposed into small services. Our teams, we went through a reorg about three months ago. I'll talk about what was prior to the reorg, and then I'll talk about what's now. Prior to the reorg, we had teams who owned the components that they tended to work on most, and then if you wanted a change to one of those components, you would make a pull request to the team. Hopefully you talk to the team first. Sometimes not, but hopefully you would, so that they kind of knew to expect it and knew what you were trying to achieve and why. The teams are each team is their own on-call rota, and there's about half a dozen components per team. Each team is a 2-pizza team. We like our food analogies at Just Eat. So that's the amount of people in the team you can feed with 2 big pizzas. So no more than about 8 or 6 if you're going some. So this means the overhead of communications within the team is quite low, because you can all sit at the same pod of desks, and probably the overhead of inter-team communication is reasonably low, and it happens because the team lead is the person on the hook for scrum of scrums sort of thing. He goes or she goes to talk to the other team lead, and hopefully that percolates up and down. But generally, you're responsible for the set of components that your team owns. What we do now is we split apart all of the different teams and compose them totally fresh. So nobody's working with people that they used to be working with day to day. Entertaining. We're now oriented on the sort of Google objective and key result model. So each team is responsible for an objective. Mine currently is do all of the things possible to make our restaurant partners as happy as they can. Another team is make a leading mobile experience. Another team is encourage new customer conversion. Another team is encourage existing customer to buy more food more often. So it's much more business goal oriented as opposed to ship technical project oriented. What we have as well as that is we have what we call COGs. I think it stands for Component Ownership Group or Coherent. Let's go with Component Ownership Group. I forget. So this is a secondary team that each person is in This is the operational team. The COG is responsible for the sustainability of the code base, the security, and the scalability of the components that COG is responsible for. The COG is the set of people on call for those components. And you're expected and desired to work on your goal team stuff more than your COG team stuff. This obviously creates some friction. So we have what we did is we wrote down how we're going to prioritize work. So the goal team nominally trumps the COG team unless there's a production incident the night before and you absolutely have to do some work to solve it. Remember, we're quite autonomous in how we choose to solve problems and how we choose to address problems. And so if there's a production incident and the person's on call, then they'll probably either work on it the next day or encourage their other COG members to work on it the next day, or all of you work on it the next day and drop the goal team work because do the thing that makes the phone not ring. It's your personal time. It's not really company time. So you want incidents to not happen, because obviously the company loses money, loses reputation when the site is down. Not that we have many of those sorts, but it's nobody wants to get an alert. That's usually the cue for someone to send me an alert because they know I'm speaking. So the COG will deal with things like removing friction from the pipeline of getting to production. And the components that the COG owns, they're kind of now developed more on an open source model. So we don't necessarily, the COG is not the set of people that necessarily write the code for those components, but they are the gatekeepers of code getting into those components, and they are the facilitators of code shipping through those components. So it'll be a goal team that wants to change components, usually, hopefully, unless something is drastically broken, and it'll be the COG reviewing the change to say, actually, I'm not quite comfortable with this going out to production without stats or without logging, or actually, yeah, go ahead, because stats and logging are automatically taken care of by my wonderful cross-cutting concerns infrastructure in this particular component. Yeah, go nuts. We don't have so many of the latter case. So I can't really speak to how well that's working. It's very new. It introduces a bit of friction between goal teamwork and COG teamwork because, some people's idea of something is on fire in production is different from others. So, I don't know, maybe I'll come back in a year or so and let you know. But I guess the major point is, both before and after, we're trusting our engineers to do a good job. That's one of the things that we try and embed into everyone when they join, is a set of core principles. Do the right thing, take responsibility, take pride, help others, optimize for throughput. So this comes back to the low feedback cycles, the short feedback cycles. Make a ticket move across the board as quickly as you can. That doesn't mean rush it. That means do all of the things that you need to do, but don't start something new until that one's in front of customers. So everyone needs to be on that page of optimizing for throughput as a whole, as opposed to, hey, I've written this piece of code and it's in review, I'll start the next piece of code because that's the more interesting bit. No, work from the right-hand side of the board to the left. So if something's waiting for deployment, deploy it. If something's waiting for review, review it. If something's waiting for coding work and has been there for a while, then offer to pair. Only then pick something off the backlog, and probably while you're picking something off the backlog, say to the team in a hip chat room or whatever, to say, hey, I'm about to pick this. Is that the sensible thing to pick? Because, well, other people might want you to pick something else, or might want a hand, or basically be transparent about why you're picking stuff. Explain why, because then people can make a better decision about whether they need to do something or get you to do something different. That's about all I had prepared. Happy to take questions. I can I can keep talking. Yes.
Let's say an example. You're on call and you receive a call, and there is an issue. You investigate and you realize that the issue is caused by something which was deployed a couple of months ago. What will you do?
That's an uncomfortable conversation.
No, I mean,
so
seriously, will you roll back? Or will you
No, we absolutely wouldn't roll back something that's been in production for 2 months. We'd roll forward. When I say someone's on call and then they fix it and then they do root cause analysis, I kind of glossed over some bits that happen. When you're on call, or when we're on call anyway, we try to first of all assess the impact. What is bleeding, and what are the options that we have right now that can stop the bleeding? So, for example, our payment provider is running slowly. Do we have a backup that we can fail over to, or can we turn off that feature of our payment provider? So, for example, say 3D Secure is having a problem. We might be willing to take the hit, the risk rather, of fraudulent transactions by turning off 3D Secure, because we know that we want more payments to go online than via cash, because that makes our business model work more, because it's easier to collect debt when, well, the payment went online, so we have the money, compared to the payment was cash, so the restaurant has the money and we have to collect debt from them. So when there's an incident, it's not about fixing a code fix, a hot fix on the fly. Very few times does that happen. It's more about, are there any feature toggles we can turn off? Are there any, can we scale out of this? Can we throw money at the problem temporarily? And Amazon lets us do that with pretty much impunity. Our finance people might disagree. So it's a lot of being on call is, have I invested some time in previous being on call, doing some upfront thinking about what might go wrong and what are my routes to come out of this? Has that answered the question? I'm not sure it has. Yeah? Okay.
If you actually fix stuff, or you just...
So sometimes we fix stuff, but sometimes we've done some thinking up front. So, for example, we do a lot of feature toggling to do soft launches for things. And, well, sometimes we just don't take that code out. And sometimes we praise ourselves for leaving that spaghetti in, because it means we've got an option for if something goes wrong, because we can turn off a feature. Sometimes not.
Would you say you still have an operations team and a development team?
So, yes and no. Increasingly, we talk about engineers at Just Eat, not developers versus operations. The Reorg has organized we've organized ourselves along business objectives, and one of the business objectives is be able to change production confidently, quickly, in small increments, and with high availability and scalability. And so there is a team focused on that, the platform engineers. They don't necessarily own production as an environment in its own right, although some of them, well, there are mixed opinions. But what they definitely own is the ease with which code gets into production. They own the road. So they own things like the monitoring service, the logging service to let us know when there's a problem and what the problem might be. They own the deployment service in terms of, nobody wants to do manual deployments, so let's write a service for that, and now automation does it. They own traffic routing, and they own the sort of crosscuts at the infrastructure level that allow us to not worry about that. Git push production, and magic happens. That's them. And we're all recruiting, just by the way.
How do you resolve the tension between a group like that, who sound as if they want to be quite conservative and safe and monitor everything and let's not break stuff?
So remember, the developers are on call, and they're on call before those guys. Those guys are the developer can't see anything in logs that indicates there's a problem. Fuck, help! They're the people that get called in if the VPN goes down or Amazon CloudFormation changes its contract and everyone got caught out by that, or those classes of problem. If for example Ireland sinks, they're the people that are going to deploy our stuff into EU Central 1.
You mentioned, or it sounded like you had a big sort of game changer when you went into the cloud, as you said.
Yep.
With increased deployments and things
Yep.
like that. I kind of have this opinion that the cloud as a term is very sort of miraculously ambiguous term.
Yeah, absolutely.
So specifically, what sort of functionality were you able to do there that you couldn't do on bare metal?
Okay, so very little could we not do on bare metal if we had the wherewithal to invest the time and effort. I mean, it's just a bunch of automation for the data center, right? Concrete things that we got from going to the cloud was, one of the going in propositions was, there's no point going to the cloud if when a server dies, it's an event. So now we manage clusters rather than servers. So who here can tell me when our peak time is?
6 in the evening.
Yeah? Hi honey, I'm leaving work. Do you fancy a takeout? It's exactly that sort of model, right? So that means there's no point running X hundred instances or whatever it might be through the morning and the lunchtime because nobody's hungry. So the cloud lets us be elastic about how many servers we're running. That we couldn't get from a data center because either would have some sort of horrendous timeshare of, delete your software and put our software. That just wouldn't happen on metal. So we use auto scaling in Amazon. Basically, it's the best cron job that ever got written. It lets me continue with my evening, knowing that I've got a reminder there that will push some more servers up when people get hungry, and I've forgotten about when it runs because it just does. What else? So servers themselves. We now have a build script for our servers, which we could have done on metal, but now that we're in the cloud, we wouldn't consider going back to metal. So our time from Amazon launching an instance to it being ready for business is between 10 and 13 minutes. And some of that is because we're a Windows environment, so there's licensing going on and there's bigger hard drives to provision. And some of that is because some of our deployment automation hasn't been updated to the faster stuff. But what happens is, because we're in the cloud, we kind of decided that, well, we're going to have fresh servers every day, thanks, because, well, we can. And that eliminates a whole class of problem like drives filling up. We don't need large drives because they're not going to be around long enough for us to write enough logs for them to fill up. It eliminates or drastically reduces the impact of memory leaks, for example, because maybe your process will get out of control, but another server will come up and you won't care because, well, another server came up and it's got some memory. Or maybe it's a slow leak, and so by the time it gets to be a problem, you will have already killed the server because that cron job will recycle them in the morning as well. So there's those sorts of things. I mean, you could have a scheduled restart for the worker processes of your websites or whatever, and that would accomplish the same thing. But here we have a totally new server. So we also have a totally new server every day, or servers every day, and that also has some security implications. It means the window of opportunity for a breach is quite small, because if they get onto a server, it's a new one with a totally new password the next day, and so their window of opportunity to actually see what's going on, if they can get in that far, is quite low. That's not something we really engineered. That's just a side effect of the way that we do our deployments manage our infrastructure. We keep our infrastructure templates. We use CloudFormation obsessively in source control, which means that they're accessible to anyone that wants to change them, which means that they can get improved as opposed to being kept in the head or wiki pages of ops engineers. We used to have sysadmins that just wouldn't write things down, now we have automation that just does it. So, we have a whole floor full of people that can read and write automation, and so they'll improve it because people tinker, right? You wouldn't get that in a data center organically anyway, or if you did, then the cost of failure is much higher because you're talking about, well, shit, I've screwed this server, now I have to repave it from scratch. You can have virtualized servers in a data center, but still, it's less trivial than it is in the cloud.
Were you on operating system on bare metal, or were you on virtualization?
A mixture. It was a real mess. So those are a few benefits. There are probably more. I can carry on talking about those if that hasn't answered the question. But yeah, okay. Yep. He's going to heckle you.
So you went to the cloud, but all those benefits,
Yep.
yeah, they're great, they're good,
Yep.
but they sound after the fact. How did you sell management on the cloud?
So I don't know. That happened above my level. All I know was I was brought into a little tiger team of we're going to move to the cloud. We've been talking about it for ages. Let's make it happen. So we took the smallest country that was Norway, that had about 3 customers and 2 restaurants, and used that as our QA environment and migrated it bit by bit and established the pattern and the sort of timeline of what should go in what order, because it was an incremental process, not a big bang. So, for example, the database moved last, and so there was some latency involved, stuff like that. Engineering, really, is not difficult. Just, think about it and plan for it and move in smaller steps. I don't know whether it was driven by top-down or above me up. Just don't know. But the benefits have definitely outweighed the disadvantages. So there was some pushback initially. The operations team, the networks team, you're going to be paying what now for a server? Well, we're going to justify the cost by making these changes this much quicker because we don't need to care about whether we break a server or not, because a new one will come up because we'll invest in that, and we did. One of the first things to do when you're on call and there's a problem and there's you figure out it's a runaway server or something like that is kill it. Another one will come back. You've got 10 minutes of slightly increased traffic and, well, then back to normal, back to your dinner. It's quite nice.
Cattle, not pets.
Exactly. We're very brutal with quite a lot of them. Not the SQL servers and not some of the others, but most things you can just shoot in the head.
What I was going to ask is, you mentioned sort of going from sort of siloed teams to cross-functional teams seemed to coincide with that move from data centers.
Yeah. I don't know whether that was planned or not.
What was about that movement that may have catalyzed that?
So moving to the cloud meant, we did it in a way that our automation was a lot cruder 3 years ago for operating in the cloud than it is now. And so that meant that the team that owned the front end suddenly owned the front end, not just the deployment package, but the server up and the AWS resources orchestration up. So we had engineers that had never seen the cloud, had never seen auto-scaling or CloudFormation or EC2 or all of those things. And suddenly we were telling them, hey, make it work. Here's a rough template, but basically it's this. Go do. And that was a bit hit and miss. King of understatement here. But it was a learning process, and we came out the other end, and we invested in the points that were particularly painful. So now, just quick show of hands, who's familiar with CloudFormation? Okay, so it's an AWS service that basically you say, here's a JSON file that has a bunch of parameters and a bunch of resource definitions. It's kind of like config management for your cloud resources. So Chef, Puppet, but for the AWS bits. Here's a CloudFormation JSON file. Go and instantiate that into a running stack. So, okay, thank you. I'll take your JSON file. I'll validate it. and I will create your instances, I'll create your DNS entries, I'll create your auto-scaling group to manage the instances, I'll create your load balancer. Great. That's kind of a high barrier to entry for people that haven't ever done that. So what we did instead, or later, was rather than make people understand the JSON files, which is quite involved and they're quite long and the templating language is terrible, but everyone knows that. What we did instead was we layered on top a bunch of templates. So who here is familiar with the MVC pattern for doing websites? Okay, great, more hands. So we applied that pattern to our CloudFormation templates. They're called templates, but they're just JSON files. So we have a master CloudFormation, which is roughly what every feature wants to be, an auto-scaling group, an auto-scaling launch configuration, which is the recipe for new servers, an elastic load balancer, a security group or two to allow things to talk, some stuff, right? Some standard stuff. And then there are a bunch of partial views that fold in or out of that, depending on some config in source control. And so now the burden of knowing how the infrastructure works is knowing where to go in source control to look at a YAML file that's about 10 lines long to say, oh, I want this machine ID to start with for my servers, or I want an ELB, or I don't want an ELB. So it's I guess the cognitive burden is much lower having invested that time. So now a developer can start, a reasonably junior person, and there's buttons in TeamCity to build, as you know, continuous integration will let you do. And then there are also buttons to deploy to QA and deploy to production. And a new developer in their first week will deploy a meaningful change to production. Compared to before the cloud, a new developer will run away screaming when told you're going to deploy something meaningful within a week of getting here. Yeah, so that's the difference, I guess.
Who makes decision when a piece of code will be released? Is it a release manager or team lead or a developer?
It's the developer. If the developer thinks they're done and someone else that owns the component agrees with them and hits the merge button, then it's going to go out. There's still a human in the loop. There's still the component owner group that will press the button to deploy it to production. But really that's a formality, and we're moving more towards not having the human in the loop.
Basically, the developer who designed the code is actually pushing the button, deploying, yeah?
Not necessarily. So, for example, I'm in the tiers of sorry, colloquial. I'm in the restaurant happiness team. We call it TRs of joy, takeaway restaurants of joy. And if I want to make a change to the public API that the native apps speak to, I can propose the change in a pull request. We use GitHub internally. I can propose the change in a pull request, so the diff is there. Someone that owns the public API will review it and say, no, make these changes, or yes, that's great, merged. I'll wait for a build of master, and I'll hit, if I have a trust relationship with the team that owns the public API, then I can hit the button. If I don't have the trust relationship, then they will hit the button on their schedule, because they own it, right? And they can choose who they allow to deploy. There's no, I guess, permission enforcement. It's a trust relationship. So we do that. That works some of the time.
The reorg you mentioned,
yeah,
the recent one. I'm interested in how fast did the team grow, and I guess that reorg happened because the team matured to the level when you can reorganize how you did. So what do you think changed over that time?
So let me think. In 2010, we were about 6 developers, 2 ops, and a couple QA. In 2012, we were about 40 developers and ops and QA. In 2013, about 100, and now about 200. I mentioned being multi-tenant, so we operate in a bunch of different countries. The UK is the lion's share of the company revenue. So the UK gets most of the engineering attention. Excuse me. Because it makes sense to grow our biggest market. And then the other 8 or 14 countries, 8 of them are on our platform, and the rest are on platforms that we acquired our way into. There is a separate engineering team for maintaining that set of components, which have a common origin but have since forked. We're bringing the fork back together very slowly, painfully, but we're doing that. So I can't speak to the reasons for the reorg. I don't know them. They happened at a level above me. Wasn't privy to that. But I guess it was along the lines of we want to be able to deliver more business we want to focus more on business objectives as opposed to have a looser focus on business objectives, and so concentrate more on shipping features compared to change for technology's sake. There was some of that. There's less of that now.
Well, it's just to me it seems like it's a rather advanced step. To organize in a way that a team does not own code, they own the delivery of a feature over a set of components.
So it's not quite that. The goal team has members from COGs, and those people that are in COGs are usually... So, for example, I'm in the restaurant happiness team, and I'm not yet in the COG that deals with the restaurant set of components. But I will be in short order, because that's where I'm spending most of my time committing code. And so I'm building up a trust relationship with the restaurant COG. And so you get kind of more osmotic, nomadic movement of people between COGs and sometimes between teams. We're very open to, someone deciding, hey, I want to do some of that now. I've been in this team for a bit. I want to do something different. Great, move. Try something new. Have I answered the question?
In a way, yeah. So I think that's partially facilitated by the open source model within the company.
It's, I guess, because the goal team work kind of sort of trumps COG work unless there's a fire in production. So I'm in the happiness team, the restaurant happiness team, and I'm actually a lead of the COG that owns the consumer set of components. And so I spend less and less time dealing with those components, and at some point I'm not going to be able to be on call for those things because I'm not shipping any code there. I don't know what's going on necessarily because I'm working on restaurant stuff. And so we'll see people move based on where they spend their time contributing. I don't know what that'll do to code ownership and having a concrete set of people that own a set of components. I don't know whether the COGs will sort of refactor over time or the people within them will move over time. It's very early days for this sort of thing. When I say the open source model, I mean the COG can say no to a pull request and say, no, this is not ready for production yet, or no, I'm not comfortable supporting this in production yet. But otherwise, shipping features is the order of the day. I'm not convinced I've answered the question, but I hope I've done okay. Okay.
So do you have ops or platform engineer guys in your teams, and if not, what's the sort of human interface between the teams and the platform?
We speak to them. So there are, I guess the level of clue of engineers in general in goal teams in COGs with operating in production is generally higher than other companies I've worked because we're on the hook for stuff. The platform engineers team is its own COG and its own team. which makes it a bit different from the goal team COGs arrangement of the rest of the floor. Payments is organized the same way. I'm not sure why. It's just the way it's panned out. So they solicit requirements for, where are you spending time that you could be shipping code? Is it painful to get alerted like this versus that? Is logging too slow? They solicit requirements and then work on removing friction from the process of getting code live and making code stay live. For example, they pioneered but then handed over the idea of running fake load every night in production. So I mentioned we do maybe 1,200 orders a minute at peak time. I don't know whether that's the exact number, but roughly. We actually pump 1,800 orders a minute through production between 4 and 8 because we want to prove that we can. And not only do we want to prove that we can, we want the computer to tell us when we can't. So alerts are targeted at the level of customer load plus fake load because that's the level we want to be able to cope with. So if a spike comes along, we can still cope with it just by turning off fake load. And that's a very easy, very quick thing to do. You stop a build in TeamCity. So that means we're insulated against spikes, and we buy ourselves time to think if the spike doesn't, if it's an actual ramp up of traffic as opposed to a ping spike. That buys you thinking room for what to do next, and it also buys you time for, if you decide to scale up, for those servers to arrive. The worst thing about being in the cloud is that new servers now take 20 minutes to arrive, or 10 minutes to arrive, rather than five weeks, because you can hurry up. Is the order of the day. The other benefit to fake load is we don't do capacity planning because the computer does that. If our alerts fire, then, we scale up or we do some optimization work. And one of the other benefits of the cloud is the optimization work can happen on the pricing dimension or on the performance dimension. We can choose, based on data, where it's worth spending time. That's also something you don't you don't get as visible in a data center world.
How do you manage change in your organization? In workflows, practices? For instance, a team decides to use continuous integration, the other doesn't. How do you manage this?
If you're shipping code and it doesn't break and it continues to not break and you don't write tests, then that's fine. It'll be difficult for someone else to contribute to that code base, but if that's okay, then that's okay. It's very anarchic. It's very chaotic. There are, on the one hand, there are lots of conventions to follow that people do, and on the other hand, people are free to experiment. So if someone wants to throw together a service with absolutely no tests and the prototype makes it into production and stays there, and no alerts go off, because hopefully there are some alerts that they might have not have written, but someone else did, then that's cool. Our director of engineering had a stand-up presentation to the AWS Summit a couple of years ago about a service he wrote that every day had an out-of-memory exception on a Windows server box, and nobody cared because, the box would die, the ELB would make it unhealthy, and a new one would come up and replace it, and the downtime would be about, 3 minutes of higher CPU, and that's fine. So I guess we're quite pragmatic with that. That's not to say that there are teams that don't use CI. That's not to say that there are teams that don't write tests. Everyone does. That's just modern software development these days. But it's not to say that we're totally anal about test coverage must continue to go up, or static analysis warnings must go down with every commit. Just as long as it gets no worse, that's fine.
Let's say you have a project which has a business value, but this project is massive. How you prefer to deliver it? By chunks, smaller chunks, which have no business value, or deliver it as a whole big thing, delivering the value to the business? And why?
That's kind of abstract. I mentioned we use feature toggles quite a lot. That lets us ship code that isn't in use, that's waiting to be turned on. So we tend to do bigger things like that. And so we incrementally ship stuff, and then we can turn it on all at once, or we can turn it on in increments. We're not quite at the level where we're doing canary deployments or blue-green deployments or A/B testing of behavior code versus CSS changes, but that's certainly coming.
How do you measure the performance of the platform engineering team? Because goal teams, it's easy to measure them on the outcome.
The speed with which code gets into production from the final commit in source control. So, for example, we were at our company world party and an incident happened and people were on call and they had their laptops and they broke them out, and so a hotfix was done because it was early in the morning. And the person writing the code, once they were happy with it, once their tests passed locally, it took an hour and a half for them to deploy that to production and verify that it was working. So this quarter, there's an effort to get that 1.5 hours down to 30 minutes because we want the ability to react quicker than that. And that 1.5 hours, that 30 minutes is overhead. All of the thinking has happened before then. So, in the typical hotfix, you might not know where to make the change. And so you're still you're buying yourself more time, that extra hour, the difference, to invest more thinking in the coding part. So that's one of the metrics. I guess the other metrics are the uptime and response time of monitoring and alerting and logging. So if monitoring is dropping metrics or because it's overloaded, or if logging is taking too long to run queries against the 220 gigs we get a day, then we want that to be better, because without that stuff we're blind, and that's back in the Stone Ages compared to what we're used to. So that's another of the sort of metrics that they measure themselves by. Stuff like that.
You mentioned that you started logging all the things basically and kind of taught yourselves how to do good logging. Was there anything what was that experience like? Because if you're going from just suddenly just skip all the data and kind of after a hackathon or you don't how did you learn what good logging look like?
So there's a really good blog post called something like Zen and the 10 Commandments of Logging. And basically things like you have trace, debug, different levels for reasons. You I guess you don't want to be overwhelmed by data, and so you want to, in production, be logging at 1 or above and not be running debug logging, because nobody has the time, the compute to dig through the verbosity of that amount of logs. So you encourage people to think why they're logging something and why they're logging at trace versus error. Error is pretty obvious, an exception just happened, but what's the difference between an error and fatal? That sort of nuance. You encourage people to think of logs as event streams rather than lines in a text file. So a log is literally a series of events, that one line per event. And so what data you fit into the event is useful or not. If you log with structured data, then you don't have to write the regular expression from hell to extract that if you need to in an operational instant, because your Logstash enrichment pipeline can do that for you, because you can think about how to do that up front. I spent, I think, 2.5 weeks creating a regular expression from hell to parse the .NET AWS SDK metric logs that they spit out, and it's really useful because now I know the error counts versus the OK counts and the different split by service, and I can extract, I can do filters on a wide variety of different dimensions. But then after that 2.5 weeks, they released a customizable log formatter, so that meant that I could log as JSON, and then Logstash would do the work for me. So it's, I guess, being aware of what would be useful. I guess one of the ways that we try and teach that is when you're debugging some code to figure out why it's broken, wouldn't it be great if it just told you why it was broken? This null reference exception is a favorite. Don't throw or return null, because then that doesn't happen. Or if it does happen, then it's really, really localized. If you can inject your logging at the seams of your classes rather than do it in line, then that's a nice place to be, because then you only have to write one logger. What are the inputs? What were the outputs? What was the error if there was an exception? And so you have one logging decorator that can fit all use cases. And then probably your logging library lets you crank up the volume or route to different log syncs, like the console, like files, like Logstash, wherever, depending on, I don't know, whether it's an error or a warning or a trace. Again, a work in progress. Yeah.
Do you still have dedicated QA engineers, and if so, what role do they play in this kind of rapid pipeline to production?
I guess we do, but they work in cross-functional teams, and they are the people that tend to pick up test automation and automation of tests. So they are the people that will come up with, say, the gherkin, but not necessarily automate the gherkin. They will farm off the gherkin for someone else to automate, because we want the developers to also write the tests. And similarly, we're getting those QA engineers to be able to review code, because if they know what has changed, then they know where to target their test runs, and they know where to target their exploratory effort. And so we're getting the QA engineers who have that, I will break this or I'll die trying mindset that developers don't have, to do that more, because that's where the value is. What unexpected idiocy can you do to this application to make it break? Customers are great chaos agents as well. So that's again why we have logging for everything. If you log at the process boundaries, then you've got a really good reproduction recipe for requests that went wrong, because you can reproduce the request. Then the only thing you have to reproduce is the data at the point in time, at which point the logs also are a benefit, because probably you're logging when the data changes. So you can reconstruct things, and you can correlate events between this API and that API. Does that answer the question? Yeah.
So who owns technical debt?
Everybody and nobody owns technical debt. It's the same. It's the same here as everywhere else. If technical debt is stopping you is stopping you shipping your feature, then it's a judgment call to fix it or improve it or band-aid it or not do anything about it and just deal with it. There's nobody that owns the wall of pain. Technical debt sometimes gets tackled at hackathons. Technical debt sometimes gets tackled by goal teams that are pissed off with the pain of changing components. Yeah. Yeah. I mean, we don't tend to work in sprints. We kind of do continuous, but yeah.
Do you distinguish between what a lot of people call technical debt and what Ward Cunningham originally came up with is his definition of technical debt? So Ward Cunningham, as far as I understand it, his original understanding of technical debt was, we don't know enough as an organisation building software to know what the right thing to build is. So we'll take on some debt, which is we might build the wrong thing, ship it, and then we'll pay the price later of having to re-engineer the product. But what a lot of people think of technical debt is really more like friction or drag. Have you got that distinction? Are you aware of that? I'm interested to know whether.
So I don't. At the level I'm at, we don't. I see the difference, but I haven't really thought about it in those terms. We certainly have people that actively and proactively work on reducing friction, and for some of those people it's their job, and for some of those people it's because they're pissed off with the friction. And we also have people whose job it is to find out that we've built the wrong thing and define some requirements to make the right thing. And so yeah, sometimes we're increasingly doing front-end A/B testing, both in the apps and in the website. And so we're running experiments before we commit the investment to decide what to build. That's still in its early stages, but we're starting to do that. And with analytics, with metrics, we're able to make data-driven decisions about that. So for example, one of the ones that we've got running at the moment is on our homepage, you end up with a text box and a search button, and you're expected to enter your postcode or where you are at the moment into the text box and hit the search button. So often what people will do is enter just the first bit, and that's a fuzzier match than if you enter the full thing. So we wanted to run an experiment to find out whether conversion would be adversely affected if we force people to enter the full thing, because then we can give them more accurate search results, because most of the restaurants deliver within X radius as opposed to this postcode, that postcode, but only a bit of this postcode, right? So if we can get more precise, a more precise question from the customer, they're going to have a better time, because we can only show we can then show them the restaurants that only deliver to them, as opposed to some that might deliver to them. And at the moment, that's converting about 1%. It's caused a 1% worse rate. So 1% fewer are converting with this, and we're considering that that's worth doing based on the data.
Yes. You said that you are not working in sprints. Is this a consequence of your changing in this automation, or did you change your agile methodologies during time? How?
I guess one of the things I haven't really talked about is we went from a very sort of large lump of change, project focused, we will do a really big project and then hope it worked kind of mode of operation, to we're going to add a new class and change a piece of behavior here and ship it, and then do it again and ship it, and do it again and ship it. I guess the process of getting from A to B, we didn't really use the words that the community uses. We didn't call it agile, we didn't call it Kanban, we didn't use the words that might engender dogma and your Kanban is not my Kanban, or Scrum but. So we kind of avoided all of that by just saying, we're going to work this way, we're going to do these things, and yeah, it might look like this, but we're not going to call it that, because then people might start to say, oh no, it's not really that, we should just chuck the whole thing away. So we kind of, we define work in Jira, hate it, but we do it. We define work in Jira. It's roughly a user story, or define the problem in the subject line, and then suggest a couple of solutions in the description. That's roughly what we do. There might be some acceptance criteria. There might not. It might be blatantly apparent what you're supposed to do. It might not. But we treat the Jiras as a start of a conversation. And I'm pretty sure there's an agile methodology that says that's how you should do user stories, but we didn't really ever call it that. We just started doing it. We tend to define work as we need it and put it on a backlog, and we tend to order the backlog, and we tend to, work right to left and top to bottom, assuming that the backlog has been kept in a priority order. So we have cards that move across the wall from backlog to next up, to doing, to review, to ready to ship, to shipped. And actually there's no shipped column, because who cares, it's in production now. Yeah, we care. And so, like I say, if something needs deploying, deploy it. Don't ask, are you ready to deploy it? It's in the column, deploy it. We have automation that actually moves the cards for us, because it's really laborious to do in Jira. If something is waiting for review and it's not in review, then we'll take it to in review and start reviewing it. Don't start something new before something's done, because now you've got context switching overhead. Some of us are better at that than others, and some of us think it's worth doing more than others. But again, it's we're not using any of the names. We're just kind of trying to ship software and trying to continuously improve. That's about as close to what the community calls it as we get. If something isn't working, then we'll change it.
Is there how it works, like for the concept of product owner? Mm-hmm. Do you have something like this in your team, or is everything?
The goal teams are encouraged to come up with their own set of key results that are in their area. So, for example, making restaurants happy means for us we're working on being more precise about where the restaurants deliver and allowing the restaurants to charge more if they have to deliver further, and because the delivery driver is out for longer, and so consequently they're using more petrol, they're not available for other orders, so the orders may need to be rejected because there's no delivery driver, and so it makes sense for the restaurant to be able to charge more for a longer trip. It's something that they've been asking for a while, and so we're building that because that's bubbled up to the top. As for product owners, I think the closest thing we have to that is the tech manager. That's the job title we have for the goal team. That person is the line manager for the people within the goal team, and also, I guess, the ultimate veto if there's a disagreement about what to work on next. But he or she is not necessarily technical. There are product managers who have never written a line of code who are tech managers. I guess we don't have product owners in the Scrum sense, but we do have collectively that role. We have the objective to make restaurants happy, and we decide roughly amongst ourselves and probably with input from other teams how to do that with a set of key results and what order we want to deliver those key results in, and how do we know that we've finished a key result? What metric did we want to move? Because we track metrics. We have a business intelligence team that tells us when conversion went up or bad orders went down, or whatever metric we're trying to move.
So how do the kind of new feature requests arrive to the goal teams? Who kind of brings them along? And does the tech manager then kind of own them and sort of dish them out, as it were, or does he play different?
We use stalks. Some of it gets distilled from customer feedback. Some of it gets distilled from the customer care center. So we've got call centers of various different teams. Some of it comes down from executives. Some of it comes from a board. Some of it comes from other engineers. You don't really have to go out and gather requirements much. They come to you. There's market research that happens reasonably regularly. There's customer feedback surveys. There is the net promoter score that we have with Opinion Labs. There's Optimizely experiment results. Any number of avenues will suggest what to do next or don't do that. And then the goal teams retrospect regularly and decide what to do next if they haven't finished what they're currently working on, or if the metric hasn't moved enough.
So you're highly anarchic and you sort of spontaneously created something that looks a little like Agile, but isn't called that thing. Was there a person or a set of people, or your core, you're those first 6 engineers in 2010 who just happened to be very mature? Because it sounds like a very mature place to arrive, and for that to have happened totally organically for some random set of engineers seems unlikely.
No, not really. So back in 2010, or rather a bit of history about the company, started in Denmark in 2001, launched in the UK, the next country, in 2005, launched in a few other countries between 2005 and 2009, rebooted the tech team and the headquarters to move to the UK from Denmark in 2009, late 2009, and started recruiting another technology team in 2009, 2010, and going forwards. Made the decision quite early on that they wanted to only really recruit seniors, people that had been there and done that a bit, rather than train people up to do what I've just talked about. And well, as with any recruiting, there were some hits, there were some misses, and the CTO on down had been there and done that, and so consequently, there was some top-down direction. There was also some bottom-up encouragement direction, because we hired smart people, and we trusted our people to do a good job, because that's why we hired them, right? So no, it wasn't spontaneous, but
It sounds like you actively shaped and matured
Yeah.
the team rather than just
yeah,
hiring
it was.
people.
Yeah, it wasn't chuck a bunch of people in a room and see what happens. It was hire a bunch of smart people that have shown to do this before and well, point them in the right direction and try and keep up.
Thank you.
Thank you.